Very good morning to all. I am Dr.C.Senthilkumar, Associate Professor, Department of Mechanical Engineering. I am here happy to share my knowledge on projection of points and lines to first year BTech AML student for the Engineering Graphics course. The topic I am going to discuss is projection of solids introduction. So here for the empathy part of design thinking, we have analyzed its basic and its knowledge, that is application. Foundation is necessary for all the engineering students, and visualization also needed to improve the ability to interpret 3D objects, and manufacturing industry student need the knowledge of crucial for sheet metal and casting process, and advanced graphics has the concept of CAD, and industrial relevance has the concept of widely used mechanical and aerospace structure. Coming to the types of prism, so we here in our engineering graphics dealing with square prism, pentagonal prism, hexagonal prism. These three has the faces, bases and side faces. The top face, bottom face and side faces or side edges and corners are there based on the geometry. For the hexagon, 6 faces, for pentagon, 5 faces and square, 4 faces are there. These are all side faces. Top face is common to all the three and bottom base is common to all these three, and moreover based on the geometry name its corner and edges varies. Let me see one by one. So let me see the pyramid types: triangular pyramid, square pyramid, rectangular pyramid, pentagonal pyramid, hexagonal pyramid and oblique pyramid. For the course of engineering graphics, students will study except oblique pyramid. So the pyramid is nothing but it is having the apex pyramid, which is having the apex, whereas the earlier one does not have apex, which is having the top face and bottom face. So which is having the axis at the center and having the square pyramid, it is having the base edge, which in every diagram represent one geometry, slant edge and triangular face. These all are indicated in the diagram respectively. So this is their pyramid type. Let me see the revolving surfaces. The cylinder and the cone are the sphere are the revolving surfaces. This revolving surfaces has the concept of having different geometry, having different axes and different material content. Let me see, when we see a problem, we will understand. For the cone, we have apex. For the cylinder, we have the axis. For the sphere, we have the radius. So let me see one by one. So truncated frustum on surface. If we cut in 90 degree, that is called as frustum, and opposite is truncation. We can see when we cut the cone, the truncation, which is showing that how the geometry is appearing. When you cut the cylinder, it is showing that one. When you cut a hexagonal prism, and when you cut a pyramid, hexagonal pyramid, pentagonal pyramid, and a cone, so which is showing its particular part geometry. That is the requirement of the diagram. Let me see the cylinder and the cone when it is positioned in the first quadrant. So cylinder having the axis which is positioned here. So let me draw the XY line. The above the XY line is VP, the below the XY line is HP. So the diagram mentioned here is the geometry's front view, which is having the rectangular shape. At the top view, we can see the cylinder shape. So usually this kind of diagram will go for the top view first. After drawing the top view, we project the projection line. But based on that, how much height axis it is having, we will complete it. So this is about the cylinder. Coming to the cone having the apex. So as I said, when you see the top view, you will see the cylindrical surface. So that cylindrical surface at the top view first we draw below the XY line, that is HP. So above the XY line, we draw the shape of the cone because the extreme ends are known. We project it and project up the apex. So this is a cylinder and cone, simple problem. Let me come to the prism position. So to understand whether edge resting, whether the corner resting, whether the corner is bisected. So prism placed with their axis perpendicular to VP in three different positions are indicated here. So usually prism is placed on the HP. When it is placed on the HP, we draw the first front view. When we saw the first front view, We are seeing here the hexagon, base is resting, and we draw the, which is 360 degree totally. When we go for pentagon, we will get 72 degree. We will make it into 72 degree here, this place, this, and A, B, C, D, all and all. So back side we indicate inside the bracket. So it's a front view, so that A dash, B dash, C dash, D dash, D dash. Back side A1 dash, B1 dash, C1 dash, D1 dash, E1 dash to differentiate it. The center axis we indicate O dash or O1 dash. So this is the front view. This case we draw the front view. After drawing the front view, we are drawing the top view. In the top view, which is indicated as the rectangular size which is indicated in the problem. This is the axis line. This is the dotted line. When you see in the top, this part is not seen, though it is indicated in the dotted line. This point also not seen when you see in the top line. It is indicated in the top line, dotted line, which is indicated name without dash because it is a top view. Similarly, for the longer edge one also indicated like this, and for the longer edge for the another pentagonal pyramid prism also indicated like this. This theta having given in the problem that one side is inclined with certain angle, so that they are projecting like this. When they say in the problem, both the sides are having the equal angle or both the angles are given. So this diagram will be taken. So for that this diagram is drawn. So this is how the prism is drawn. Let we go for the next one. So in the MCQ, we understand when the axis of a solid is perpendicular to horizontal plane, the parallel to the vertical plane, which view shows the true shape of the base? So the top view, because true shape always will be seen as I said in the problem, the top view. Next MCQ is which of the following is the first step in drawing the projection of solid resting on its base on the horizontal plane. So that draw the top view showing the true shape of the section as we indicated. So with this, when we see the reference, I thank everyone for listening the problem. You can ask questions in the message also. Thank you very much.